Hello friends. So today we are here for another session for interview preparation. Uh, so we have covered the basics of data science and Python. Some questions on Python also we took. So let's go towards statistics and basic terminologies used in data science. So let's start with today's first question. Okay, let me increase the size. Okay, so today's first question is, what is data warehousing? Yeah, so what is data warehousing? Okay, so data warehousing is a process to collect and manage data from multiple sources into a centralized repository to drive actionable business insights from it. We can say that it is like a electronic storage space for all the business data integrated from different sources. Okay, let's take the next question. What is data mining? Yes, friends. Does anyone know what is data mining? Okay, so I shall answer. Uh, it is the extraction and discovery of patterns in large data sets involving methods relating to machine learning, statistics, or database management system. So it is, we can say it is an interdisciplinary subfield of computer science and statistics with overall goal to extract information and transform it into a structure which we can use further. So in data mining, we extract or discover patterns in large data sets, which is involving methods relating to machine learning, statistics, or database management system. So it is a combination of both computer science field and statistic field. Okay, so let's take the next one. Why data mining is a misnomer. Misnomer means the name is not appropriate for the definition. I mean to say, why is data mining not appropriate for its definition? Okay, so data mining is a misnomer because uh, we do not actually mine for data. We mine for patterns, underlying patterns in the data set. So it is a misnomer. It's not, its name suggests that we are mining for data, but we don't mine for data. We just extract the underlying patterns that is in the data set. So that is why it is a misnomer. Okay, let's get to the next question. So what is ETL? Yeah, Naveen, correct. So next question is, what is ETL? Yeah, Naveen, correct. So ETL is a data integration technique that involves three steps, namely extract, transform, and load. It is used to blend data from multiple sources into a usable format and load it into a system that users can access it. Okay, so we said ETL is a data integration technique. So what is data integration? Okay, so data integration is the process of combining data residing in different sources to provide with a unified view of them. And so from different sources, we collect the data, combine it, and provide the users with a unified view of them. Okay, so let's go to the next question. What is data wrangling? Okay, so data wrangling is the process of transforming and mapping data from one raw data format into another format so that it is more appropriate and valuable for the downstream users, or we can say downstream purposes like analytics. It is actually not cleaning, it involves also cleaning. So data wrangling, yeah, so data wrangling also includes three other process like munging, data munging, then visualization, and aggregation. So next question is, what is data munging? So actually data wrangling and data munging are basically the same process. It is just the initial process of refining raw data into formats which are better suited for downstream users. Yeah, it is no, it actually refers to refining. It refines the data. It refines the data into a better format, which is better suited for the downstream users mainly. So next is, what is data cleaning? Yeah, cleaning the raw data is correct. Yeah, more precisely, we can say it is the process of finding and correcting inaccurate data in a particular data set. So our main goal in this is to remove inconsistency without changing the data sets, so that it can produce good insights. So we can say here main point is remove inconsistency. Okay, so next question, what are the benefits of wrangling? So we know wrangling is the process of transforming the data into a more appropriate form. Yeah, so what is the benefit of transforming the data into a more appropriate form? Okay, so when the data is better formatted, it enhances the user to have ease of access. Yeah, correct, Rishi. Yeah, Naveen, you are also correct. So ease of access, as it is transformed, the data is easy to access. Then we have faster time for gaining the insights. Basically, what Naveen said, it saves time. Yeah, easily understandable, and we can say it increases the efficiency. Okay, so next, what is the benefit of data cleaning? So basically, data cleaning is the process of finding and correcting inaccurate data uh, to remove inconsistency without affecting the information in the dataset. So what are the benefits? if we clean the data, what benefits do we get? Yeah, we can say minimize risk as it increases the integrity of the data. You can say that. So let's see. So first of all, it removes error data. Yeah, it improves decision making purpose. So it removes the error data first of all. Then we can say it reduces the cost which may incur due to error data. And we can say it improves integrity of data. Then it improves the quality also. Quality of data. Okay, so let's go to the next one. So what are the different processes involved in data cleaning? What are different involved in data cleaning? Actually, it improves decision making process, but decision making process involves other things also. Uh, like we require the algorithm, correct algorithm, then hyperparameter tuning, all that is also involved in making decisions. Yeah, Anand. Basically, all the data preprocessing is done for data cleaning. Okay, so let's discuss. Uh, First, we can say it is process involves removal of irrelevant data. Similarly, we can say removal of duplicate data. Then another one is fixing typos. Basically, all the data preprocessing techniques, whatever you use, converting data types to appropriate format. Transformations also. Now, then we have missing value. So actually, missing value How can you how can we deal with missing values? There are a number of methods to deal with missing values. So can anyone say how do we deal with missing values? Yeah, correct. So basically we have removing removal, which is what Rishi wrote, drop the inner values. Then we have imputation. I think we can also copy from the similar data sets. But it is not used widely, this one. Okay, so let's go to the next question. Sorry for that. Okay, so what is a normal distribution? So we're coming to the statistics part. No, identifying outliers, I think it comes under EDA techniques. Okay, so what is normal distribution? Now here we start, we are coming to statistics part. Yeah, so yeah, ranges between 0 to 1, right? So normal distribution, or we can also say Gaussian distribution. Yes, yes, yeah, exactly. Yeah, Ashish, yeah, correct. So it is a probability distribution curve that is symmetric about the mean. Arishi will be coming to right skew and left skewness after this. So it is a probability distribution that is symmetric about the mean. And here mean is equal to median is equal to mode. So next, what is kurtosis? Yeah, Rishi, correct. Anand, they are also correct. Okay, so kurtosis is the tailedness, or we can say thickness of the tail of the normal curve. Okay, let me write. So if we have this curve, so if we have a curve like this, so thickness of the tail is called as kurtosis. So for a normal distribution, yeah, high thickness means number outliers are present. Yeah, Rishi, you are also correct. So for normal distribution curve, we have kurtosis equal to 3. Okay, so let's go to the next question. Yes, yes, you are correct. What is skewness? Yeah, correct. Appreciate. So skewness is the measure of symmetry of the normal distribution. So basically, if it deviates from the symmetry, we can say the graph is the distribution is skewed. So we know it is of two types, positive and negative. Yeah, correct, Ashish. So next is what is negatively skewed distribution, or we can say Negative means left. Skewed. Okay, so left skewed is a type of distribution where more values are concentrated on the right side and left tail is longer. So here we have mode is having the greatest value, then we have median, then we have mean. Similarly, what is positively skewed? Or we can say right skewed. Yes, you should correct. Yeah, Rishi, you're correct. If you're saying for positively skewed. So positively skewed is a distribution where more values are concentrated towards the left side while the right side tail is longer. So here we have mean is the greatest value. Then we have median. Then mode. Yeah, Rishi, you're correct. Okay, so we'll see next. What is bias? So friends, what is bias? Okay, so bias is a type of error in data science modeling when we use an algorithm that is not strong enough to capture all the underlying patterns or trends that are existing in the data. So what we have is when we train Yeah. So what happens is we get an underfitting model. So in bias, we have an underfitting model. And examples of this are linear regression, also logistic, so next, what is variance? Yeah, Rishi, correct. Underfitting model we get from bias model. Yes, is correct. So what is variance next? Okay, so variance is a type of error in data science model where the algorithm is too complex and it learns the features of the data set along with all the noise in it also. So this occurs if the pattern in the data is quite easy to discover, but the model trained has very high complexity. So what happens is this model performs very well on the training set, but it performs very poorly in the test data set. Yeah, correct, Ashish. It is the spreadness of the data. So generally, variance causes overfitting problem. And example will be decision tree. When we train a decision tree on a very simple model, means very simple data set, it will overfit the data set. Okay, so next is what is overfitting? Overfitting and underfitting. So as we previously discussed here, here and here, underfitting is a case where we train the we take the model, a very simple model to train a complex data set. So it doesn't pick up all the information from the data set, and hence we have a model which is not properly trained. Whereas overfitting, on the other hand, when we use a very complex algorithm on a very simple data, it picks up all the noise data also from it. Yes, is correct. So this is what we have discussed also here also. So let's go to the next question. What is yeah, correct. Ashish and receive both. Yeah, correct. So what is regularization? Next, we are going to regularization. Okay, so regularization is the technique that prevents the model. Yeah, it prevents, basically you can say it prevents overfitting by adding extra information to the data set. Yeah, so what are the types of regularization? Yes, yes, correct. So we basically have two types: lasso, then ridge. It is also called L1 regularization, and this is L2. So L1 tends to shrink the coefficients to zero. This shrinks coefficients to zero, and this shrinks the coefficient to even. Evenly. So L1 is used for feature selection. L1 is used for feature selection, and L2 is useful when we are dealing with collinear or co-independent variables. Okay, so let's take today's last question, then we'll close it. What is bias variance trade-off? Yes, is correct. Now, basically, lasso is used for feature selection. Range can also be used, but lasso's main use is that feature selection. We use lasso as we can drop any variable which is associated with coefficient that shrink to zero. Basically, that is why we use L1 to means L1 for feature selection. Okay, so coming to bias variance trade-off. Yeah, we can say that. So actually, bias and variance complement each other. The increase in one will result in the decrease of the other. So basically, we have to find the right balance between the bias and variance. So this balance is known as bias variance trade-off. So if we give an example, like if a KNN algorithm has low bias and high variance, so we can do what is we can modify the trade-off by increasing the k value, which increases the number of neighbors contributing in the predictions and which consequently increases the bias of the model. So KNN, which had high variance, by increasing the k value, we increase the bias of the model. And by doing that, we can balance the bias variance trade-off. Okay, so friends, we will close this now here, and we'll be coming now we cannot have both low variance and low bias, if we decrease one, another one will increase. So we have to see the balance which gives us the best model. Yeah, so friends, uh, we are out of time, so we'll be closing it now. So meet you, yeah, so meet you tomorrow.